Okay, so this will be recorded and will be available on the SharePoint after this lesson. So first point we're looking at was gravity and weight. What is weight? Weight is the force of gravity. Okay, that depends on the object that is causing the gravity. So for example, Earth is a small planet, so a small force of gravity, a small gravitational field strength, I should say, means a small weight. Jupiter, that's what the J is, again represents here, it's got a big gravitational field strength, so on Jupiter you would have a big weight. So weight is the force due to gravity. Okay, so every object that has mass, which is basically every object, has a force of gravity. Your pen, for example, has a force of gravity, so that pen is attracting you. Even from here, you can't feel that force of attraction because this is very small. You can feel the force of attraction from the Earth because the Earth has got a bigger mass, so therefore a bigger gravitational field strength. One misconception here, G is not a force. G is gravitational field strength, okay? It isn't a force itself. That's what causes the force. So weight is a force due to gravity. The bigger the gravitational field strength, the bigger that a attractive force, in other words, the bigger the weight. We have an equation which must be learned. So equation is weight is mg. So basically weight is proportional to mass. So the mass of the object, such as this pen, will be the same here as it would be on Jupiter, as it would be on the moon. But the weight of this pen, because the gravitational field strength G is different on the moon and Jupiter and Earth, the weight will be different on each of the planets. So that's why we say weight is proportional. This symbol looks like a fish, is the symbol for proportional. Weight is proportional to mass. So in other words, if the mass doubles, the weight doubles. The mass triples, the weight triples. Okay, and then the constant, the gravitational field strength, is what determines the relationship between the weight and the mass. So on Earth, G is equal to 10. So the weight would equal the mass times 10. So 100 grams, 0.1 kilogram times 10 would give you 1 Newton. On Jupiter, G is actually 24, so almost 2.5 times bigger weight. On the moon, the value for G is 0.16, so about 1/6 the weight would be on the moon. So this pen would be a mass times 0.16, so its weight would be 1/6 what it is on Earth. Okay, you need to know that equation. That's one of the simplest equations. Hopefully you should all know that because you've probably come across that even in primary school. Get one of the equations you need to know and learn. W equals mg. Now, if we take an object, again, if I try my pen, I can balance this on the middle of my finger like this. If I try to balance it over there, it'll fall down. That point where I balance it is called the center of mass, okay? The center of mass is the point through which all the weight appears to act. So we can simplify the forces on an object by acting all the force, all the weight coming from that center of mass. Now if we can move this without disturbing the whole thing, there we go. So our center of mass is this point where all the weight acts from this point. Okay. We've done an experiment in the forces book, and in the class you've done this, how to find the center of mass. Okay, something like a donut, for example, a ring donut. If you have, those ones with the hole in the center of mass is in the middle where the hole is. So the center of mass does not have to be actually on the object itself. How you find the center of mass of an object, this here is the object. Okay, if I suspend or hang the object up from this point here, so it's held by a piece of string, okay, then if I draw a line vertically downwards through the object, the center of mass will be on that point because all the weight acts from the center of mass. So the weight will be pulling down through there. If I then change the position to rotate it around, say this is where I hung it from the next point. So if I hang it up and rotate it around, draw a line straight down, we'd have another one. Where those two lines cross is your center of mass. So basically you hang the object up, you draw a line straight down from the point where you hang it. Okay, so like point A. then you would select a different angle. So you'd hang it from a different point. So, and this will be the line B. So repeat the procedure, draw a line straight down. In this case, it's not straight yet, but when you hang it, it will be straight down. Where those two lines cross is the center of mass. And the point for the center of mass, I'll just let in amber, the point for the center of mass is it doesn't have to be on the actual object. It could possibly be off it. Basically, the center of mass is the point where all the weight acts from or appears to act from. Okay, so that's all the information you need on gravity. Right, the next section was resultant force. So the resultant force is basically, result means the answer. So the resultant force is the answer when we add all of the forces together. So we've done a bit of it there when we've done the vectors. So 2 newtons plus 2 newtons gives you 4 newtons. That is the resultant, okay, when you add the forces together. So if we look at an example of an airplane, so there's a free body diagram, not quite accurate because I've actually drawn the plane rather than a dot. So normally if you're doing a proper free body diagram, you just have a dot as the object, okay? I wanted to make it a bit more picturesque here. So an airplane flying at constant speed would have 4 forces acting on it. The upthrust or the lift from the wings, the weight of the plane itself, the thrust or the forward force of the engine, okay, and the drag forces, which is the air resistance as the plane is flying through the atmosphere. So those are the 4 forces that would act on that object. If you add all of those together, I've drawn them so that the arrows are equal or approximately equal. So remember, on a free body diagram, the size of the arrow represents the size of the force. So the thrust and the drag are the same size, going in opposite directions. The upthrust and the weight are the same size, going in opposite directions. So adding those together, you end up getting 0 because they cancel each other out. So in this case, this has a resultant force of 0. Okay, so the overall force on the plane will be 0. And that means that plane will be flying at constant speed. Okay, we'll look at in a later section, forces 2, the Newton's laws, but this is Newton's first law. When the resultant force is 0, the object is either stationary or constant speed. In this case, the plane is flying, so it's a constant speed. Okay, so all you do is add together the individual forces on the object, and that equals resultant. In this case, it equals 0. If that plane were to accelerate and that thrust force was getting larger, so the pilot turned up the engine, now the resultant force would not be 0 because the thrust force would be greater than the drag. So the plane would have a resultant force, so therefore it would get faster. Okay, so I've just drawn this example, so the resultant is 0. Okay, right, this bit is it for higher theory only, so I'll just do this quickly for the recording. So, components of forces. We can represent a force like this. And the components of the force are the horizontal and the vertical forces when added together would equal this force. So if we do the vertical first, you start at this point, follow the arrow up, then follow across from the horizontal arrow, and you end up at this point. So that is a way of representing a force at any angle by 2 forces called the components at right angles to each other. The reason for doing this is because it's much easier to add forces which are in the same direction, such as these two. 2 newtons plus 2 newtons in the same direction gives us 4 newtons. If we have 2 forces at odd angles, we can't really add them. Okay, so the components are basically the 2 equivalent forces which added together will give you the force itself, and they're at right angles, which means we can allow us to add verticals and horizontals together. The other way of working out the resultant force is something called the resolution of forces. So in this case, we've got 2 forces, F1 and F2, okay, at odd angles to each other. Accidentally drew them at approximately right angles here. That's pure coincidence. But another way of finding what the resultant of those 2 forces added together would be is we make a parallelogram. So the green dashed lines are the opposite sides of the parallelogram. Okay, draw your parallelogram drawing the opposite sides, and then the resultant force is simply the apex to the apex across the diagonal, and that will give you the resultant force. You'll be asked to know these as scale diagrams. Lovely. Okay, I'll stop.